Okay. What we're going to do now to simplify this a bit is we're just going to take and divide each of them. Since they're all equal to each other, we can divide them all by the same thing to simplify. And we're going to divide them by b times c times d. B times c times d. And this will simplify them quite nicely, actually. So divide them all by b times c times d. And then we can start canceling what's on top and what's on bottom. So here's a c and a c, right? I can cross that off. You know what? I'm going to add the 1/2 in here too. Sorry. Add the 1/2 in there. We're going to cross that off and that. Oh, look at what we have left here. The sine of capital B, angle B, over the side B. Interesting, right? If we do the same thing here, the B's cross, the C's cross out, and what do we have left? The sine of D over the side D. Cancel, cancel, cancel. What's left? The sine of C over its opposite leg, or side, right? Okay, so what we're left with now becomes the law of sines. You can use these very handy ratios to solve any triangle. It doesn't have to be a right triangle. That's the beauty of it. It doesn't have to be a right triangle. It's interesting, okay? The sine of D over D. The sine of C over C. Does it necessarily have to be these letters? No. All you have to keep in mind is it's the sine of the angle that you're using and its opposite side. That's all you have to keep in mind, because you may not always have the same letters, right? So you may see it, I think in the book, it's written like this, the sine of A over A, but it doesn't make a difference. The sine of B over B. It's just the angle that you're using and its opposite leg. That's how it's written in the book. Doesn't make a difference what letters they are. Cool? Let's practice this to help us solve these triangles. So again, this is for using solving any triangle. It doesn't have to be a right triangle. So use the law of sines to solve the following triangles. So I want you to draw a line here because we're going to have quite a bit of writing. This is going to be for this triangle right here. So let's look at, we have to solve it, which means we have to do what? Find everything that's missing. Well, it's easy to find that angle A, isn't it? How would you do that? Let's start with that.
Subtract 85 and 34.
Exactly. 180 minus 85 minus 34 degrees, and you get 61 degrees. So I'm just going to tell you what that is. Easy. Now, let's take a look at this and use the law of sines. We have angle C, and we have its opposite side, don't we? So that's going to be one of the ratios that we're going to use to help us find these other two sides. So using, you can use two of these to solve. You can just use two. So I'm going to set it up as the sine of 85 over its opposite side equals, now let's try and find AC right now. I have that angle measure, don't I? So I could say that would equal the sine of 34 over, I don't know, my unknown. Let's just say it's lowercase b because it's opposite capital B. Oh, if I just use those two ratios, I have a proportion with only one unknown. I can solve for that, correct? By cross multiplying. Does that make sense? That's how you use this. So we're going to cross multiply. Let's do this all in one fatal swoop on our calculator. Got a calculator? Okay. So remember, when you're solving for the one unknown, cross multiply the two that you do have. Yes? So the sine, sine of 34, close the parenthesis, times 12 And then I'm going to push enter here. And then once you do that, you divide by this remaining one, and that'll give you B. It's basically just skipping the setting up, right? It's really easy to solve a proportion. Okay? Now I'm going to multiply. Yeah, what? Did you close the parenthesis?
Yeah.
Are you using the Inspire? I don't know right now. I'd have to look at it. Why don't you come and get an 84? Come and get an 84. Okay? I'll figure that out. I just don't want to do it right now. Okay, now we did this cross multiplying, then we just have to divide by the sign of 85. So you multiply the two you have, and then you divide by the sign of 85. I always like to close the parenthesis just to be safe. Enter. And what did we get? 6.7. And we're going to round our answers to the nearest tenth. So this tells me that B is equal to 6.7. Let's put approximately. So I'm just going to write that right up here just so I know what parts I have. I only need to find one more side. It is not a right triangle, so can you use a Pythagorean theorem?
No.
No, but you just use another ratio. Just pick another ratio. It's no big deal. So here I found, I should write here, find B. Now I'm going to find A. I'm going to find A now. A is here, correct? It's opposite that angle. So I'm just going to pick one of my ratios. It doesn't matter. I'm going to use 61 degrees. I'm going to say, okay, I know that the sine of 61 over A, that's my unknown, is equal to, I can pick either one. It doesn't matter. I'll do 85. The sine of 85 over its opposite side, which is 12. I have a proportion with one unknown. I can find that unknown. Okay, so how did I do this now in one calculation?
Sine 61.
That times that, and then divided by the other one. Right? Now, if you don't like that, just set up the cross multiply. Write it out if you need to. Yes?
Last time I did like it all in one where you like 61 times 12 and divided by.
Did it work?
Yeah.
Okay, that's good. That's fine. I just like to be safe, and I always do this, but it doesn't really matter as long as it works. Divided by the sine of 85, and you get 10.53, which we will round to approximately 10.5. So that's 10.5. So I've found every single part of that triangle, right? But look what else we have to do. Find the area. Yes, DJ, back here, yeah.
So you would divide sine of 61 times 12 divided by.
Yeah, sine of 85. Yep. It's just a quick solve of a proportion. If you rather write it out because you don't remember, then do it. Yeah. Okay, let's find the area. We don't know the height of this triangle, but we can use these to find the area. So that's why I was refreshing your memory. Remember we said, okay, what two sides do you want to use? Pick two sides. I think I chose 12 and 10.5. So I'm going to use these two, and then I'm going to use the angle in between for my area formula. So I'm going to say the area is equal to 1/2 12 times 10.5. If I use these two sides, then I have to use the sine of what? 34. That's using this formula up here. That's why I talked about that earlier, okay? Times the sine of 34 degrees. If I put that all in my calculator, I can get the area. Pretty cool, huh? You don't even need the height. So let's do that. So I'm just going to convert 1/2 to 0.5 times 12 times 10.5 times the sine of 34. Did you get that? Okay, then let's round it to the 10th, and we're going to say the area is approximately 35.2 units squared. Cool? Okay, let's do one more together then, and then I'm just going to set you free to practice this. Okay, so we have to solve this one. Now here we have two sides and only one angle. Doesn't matter. I'm going to find angle C first. So I know I have to use this ratio right here because I have angle B and I have its opposite side. So this is lowercase b, right? This is lowercase c, and this is lowercase a here. Okay, so I'm going to say the sine of 110 degrees over its opposite side is one of my ratios. And if I want to find C, I chose C because I know its opposite side. I'm going to say, okay, that's equal to the sine of C over its opposite side. Now, before you go pushing buttons, I want you to think about this. When we solve for this, are we going to actually get the angle measure? No. We're going to get the ratio. And then we have to use the inverse to get the angle measure. Okay? So think about what you're solving for before you just jump in and leave your answer. So let's do this. We're going to do sine of 110 times 13. And then I'm going to divide it by 21. So you do this, and then you divide by 21. Okay, this tells me that the sine of C is equal to, let's go a few places here. Don't erase don't clear your screen, because we're going to take that number right off of there and use it. Okay, so I'm going to show you how to do that. It's 0.5817 ... right? Now, I don't want the ratio, I want the angle measure, so I'm going to do this, sine inverse of this number. So you can do it without clearing it. Don't clear anything. Push sine inverse, and then you're going to recall this and put it here by using this. Look right above the negative. What does it say? In blue, what does it say? Answer. So you want to do this, second negative, and then it puts this number in there. Got it? Do you get that? Push enter, and there's your angle measure. Nifty shortcuts, right? Okay, so that means that C is equal to, let's round, 35.6 degrees. Now I can get angle A by subtracting. So angle A would be 34.4 degrees if I subtract 180 and all those numbers. The last thing we need is what? What side do we need now? Side A. So I'm going to set up another ratio. The sine of 34.4, I got to use that one because I need to know this, over A. And then I use a ratio that I have both the numbers for. I think I did the 110 again. The sine of 110 degrees over 21. Cross multiply what you know and divide by the third thing. So sine 34.4 times 21 divided by the sine of 110. Did you get that? Okay. So A is approximately 12.6. So just to be sure I have everything, which I think I do. This is 12.6. I'm good. However, we still have to do what? Find the area. You try it. You try it. Does it matter what two sides and what angle you use? It doesn't. If you do it right, you'll get the same area. Okay? So So I chose to use these two with the angle in between.
Oh.
Okay, so it's 13 times 21 times the sine of 34.4 degrees with the 1/2 as well. Did anybody use different size with the different angle? Because I want to just curious if you got the same answer. You should have. Yeah? Nobody? Everybody used these two?
Yeah, I worked with
Oh.
4.6 and 21.
Yeah.
Okay.